Hello everyone, this is Muhammad Idris. I am from Afghanistan. I am second year PhD student in Kumamoto University, Japan. I belong to Civil and Environmental Engineering department. So now I am going to present my research work which I have done during my master program. These are the contents of my research. So first of all, introduction. Uh, concrete. Concrete is the most commonly used material after water. It is mainly consists of Portland cement, water, and aggregate. It has some benefits such as good strength, ability to cast in different shapes, harden at ambient temperature, and more. Portland cement is not environmentally friendly material, as it contributes 5 to 7% in emission of global carbon dioxide. Uh, Now I'm going to give some information regarding waste concrete. Annually 1 billion ton of waste concrete is produced in Europe, USA and Japan. The majority of the debris is wasted and disposed in landfill, and environmental problem is created by disposing them. Here we can see in the left side the picture of waste concrete debris. Waste concrete can be recycled, and when we recycle waste concrete, recycle aggregate can be produced. They are used in concrete to replace coarse aggregate. When recycled aggregate is used in concrete, the property of concretes can be decreased due to high water absorption of recycled aggregate. To improve the properties of recycled aggregate concrete, in this research, I use paper, sludge, ash, and silica fume. Moreover, in this research, pulse power device is used to produce high-grade recycled aggregate. Waste paper is another kind of waste, and it was estimated that by 2020, half billion tons of paper would be produced. An environmental problem was created by disposing these waste in landfills. And some research shows that uh, when when papers are burned or incinerated in 800 degrees Celsius, uh, it is converted to pozzolan. And pozzolan are material that when they are used together with cement, they can produce pozzolanic reaction. Uh, they react with calcium hydroxide of cement and produce CSH gel, which improves some properties of concrete. Uh, Moreover, paper pellets can be made from papers, and these paper pellets have 4,000 kilocalorie energy uh, per kg. Silica fume is ultra fine byproduct of silicon process industry. It has amorphous shape and highly reactive silica. It is widely used in field of construction. It increases permeability of paste and increased strength and durability of concrete. Pozzolan is widely used in concrete to increase strength and durability, reduce shrinkage and permeability, and more. So here we can see that silica fume contain 96.5% silica, which is very good for being a binder. And also here we see that PCA, paper sludge ash, contain good amount of calcium oxide, silica and aluminum, so they can be a good binder. So what is the aim of this research? Uh, the aim of this research is to develop waste material and use them in concrete to improve their properties and reduce environmental problem. Uh, so if we have small or lease area for landfill, then we will have a large or more space for beautiful nature. So our aim of this research is to decrease the amount of waste. Objectives: paper sludge ash, silica fume were used with different percentage of recycled concrete aggregate in concrete to study the following properties of concrete, which are workability, strength, and acoustic emission behavior. Methodology: these are the material which were used in this research, and these material are ordinary Portland cement, paper sludge ash, silica fume, crushed stone and fine aggregate, high grade recycle uh, coarse aggregate, which were produced by pulse power discharge. Uh, in Kumamoto University, we have a device that can crush and produce recycle concrete aggregate from waste concrete, and high quality of recycle aggregate can be produced by this pulse power device. Experiment: in this research, overall 15 types of concrete samples were produced. 5 and 10% of cement was replaced by PCA and silica fume. 10% and 20% of coarse aggregate was replaced by RCA. Here we can see the mixed proportion of the samples. The water cement ratio was kept to around 0.5%. Results: from the result we can see that 5% silica, 5% paper sludge ash concrete slightly, and 10% paper sludge ash significantly decrease the workability of uh, concrete. And here also we can see that recycle 10% recycle concrete increased 10% and 20% recycled concrete increase the workability of concrete. And also here we can see that 5% of silica fume increased the workability of concrete, but 10% silica fume reduced or decreased the workability of concrete significantly. This is the 28-day compressive strength result, and here we can say that 5% silica fume and also 10% paper sludge ash concrete increase the compressive strength of concrete, um, but here we can see that 10% silica fume significantly increase the compressive strength of concrete. And also we can say that both silica fume and paper sludge ash improve the compressive strength of recycled aggregate. Here we can see that 5% silica fume increase the compressive strength of 10% recycled concrete, and here we can also see that when 5% and 10% paper sludge ash use it with 20% recycled aggregate, the compressive strength was increased, and same happened when 5% and 10% silica fume was used with 20% recycled aggregate concrete. The same result can be found here for 56-day compressive strength result. This is the acoustic emission behavior result of samples. From here we can say that acoustic emission activities were lower at early stage of loading. Here we can see that the acoustic emission behavior were lower at the early stage of loading. But it was found that cumulative heads were lower in concrete with PCA and SF concrete, and this showed that PCA and SF concretes were denser and had higher robustness than the other concrete samples. Workability of concrete was decreased when the percentage of PCA and silica fume increased. Both the binder PCA and SF improved the compressive strength of concrete and recycled aggregate concrete. The acoustic emission activities were lower at early stage of loading for all types of concrete samples, but it was found that the cumulative heads were lower in the PCA concrete, and this shows that PCA concrete were denser and had higher robustness than the other concrete samples. High quality recycled aggregate didn't have any negative influence on properties of concrete, but increased some of the properties of the concrete. The compressive strain and AE test results showed that both PCA and SF were pozzolanic reactive, and pozzolanic reaction can be occur inside concrete when they are substituted with cement. These are my references. So thank you so much for your attention.